Next lecture, next talk. We're minus 1 minute to the beginning. Okay.
Zapowiadajte, welcome.
Welcome back in here offline. Welcome online audience, and welcome to the whiteboard here. So you can write your name and topic for the lightning talks. Here is the whiteboard. And now, our next speaker is not just a person. It's two persons.
They both are members of technical staff at VMware Carbon Black Bulgaria.
Desislava has been software engineer for 6+ years. She started her career as embedded developer with C language. Desi has spoken at online events such as Women Who Code and ISTA conference in 2021. Beside her work, she loves exercising and cooking. Also, she takes care of her two lovely cats.
Victor is a data scientist working in security analytics. He enjoys machine learning that can be applied to improve the user experience and overall functionality of a product. He is also a passionate hobby photographer, hiker, runner, and piano player.
They are here to tell us about the vital aspects of product life cycle.
Your applause for
Desi
and Victor!
Thank you.
So yes, testing, everyone can hear me. Hello everyone, this is Desi.
And this is Victor.
But I'm sure you already guessed that from the intro we got. And yes, we're going to be the folks who are going to be presenting right before the lunch break. So, keep the hunger at bay just a little bit longer.
Today we are going to present our vision of the vital aspects of product data lifecycle. We are aware that not everybody here is a data guru, mostly because our friends didn't fail reminding us about it in the past few weeks with comments like, "Oh, I'm not the data guy, I probably won't get anything," or "Your intro was amazing, but I only remember you mentioned your cats." So I can relate to that. My cats are adorable, but also up until 1.5 years ago, this domain was absolutely new to me. So don't worry, we are not going to torture you too much.
And right, so of course, before we can talk about the product data lifecycle and why that's important to your organization, to manage your data, how to set it up and so on, we first need a product. So first of all, we chose something that's probably everyone's can relate to, has heard of, and also for another reason that, if we could think of a super original idea, we wouldn't be here presenting it on an open forum, we'd be developing it and making millions off of it. So the topic we chose is this innovative product called Quack. And yeah, what the duck is this?
We hope that everybody here have heard about Slack because we've developed a copy of it. With the help of God, aka our sales team, we found some customers, and even though we started this idea as a joke, we want to become a serious company now. So we set some business goals to make sure that our customers are satisfied and happy with our offering. And before I continue with the business goal, I want to do a quick reminder. All of the examples we are going to use with Quack are completely fabricated and imaginary, so don't bother to think about the different laws and policies and regulations you have heard of, because they may not comply with these examples. So after we clarified this, let's continue with the business goals we've set about Quack.
So what are two of our main business goals at Quack? Well, firstly, we want to nurture our customer base. So what does this entail? Well, it entails keeping our current customers happy, making sure they keep using our product, don't cancel their subscriptions, trying to win new customers by enticing them to buy subscription, making our product as great as possible. But this is usually the domain of sales, marketing, customer success teams. And while there's great data to explore there, we're going to focus on something else which will help us explore the data lifecycle a bit more, and that's improving UX, the user experience.
We've identified that to improve the UX of Quack, we need to focus on these three main channels. Our features, the automation we provide via a chatbot or personal assistant, and the APIs. And for each of these channels, we are aiming to understand two things. First of all, how does customers are interacting with the current capabilities and functionalities that we have? And second, do we have any gaps to fulfill and room for improvement for each of them?
So for example, for the first one, for our features, we're looking at exploring our things like, our features like emojis, or as we call them in Quack, quackers. Yeah, very original. Things like, exploring introducing threading in channels, where people can reply in comments, etc. And essentially answering questions like, how often our users use existing features? Is there any gaps there? When we introduce new features, do users engage with them, or are they not so successful? For automation and chatbots, we're interested in understanding, is there any functionality that our users we can automate, and there's common tasks there that users perform. For example, being able to set up a Zoom meeting when a user types, set up a meeting with Peter through Zoom for 7 p.m. tonight.
And our APIs, they give the ability of the customers to build any extensions or applications or capabilities that we do not provide out of the box with the features and the chatbot regarding the integration and automations that Victor has mentioned. And for them, we are trying to understand, first of all, do we have any use case that we do not cover currently? And how is the current features used in our APIs?
So what do we need to do to, first of all, make this a reality? Well, firstly, we need to understand what data we need to collect. So for example, for our features, we might collect things like how often people send or react with our emojis or quackers, what kind of emojis they use often, do people engage in threads more often than they do it directly in a Quack channel. For our API usage, we're going to collect, of course, which features of the API users use, how often they use it, what kind of requests they request. For the chatbot and automation, we're interested in scraping the text contents of messages people send to each other. And
after we have the data types identified, we can continue with finding what are the data sources that generate this type of data in our application. These are mostly different tools and technologies in your product. And for Quack, for example, to collect API metrics, we can use the load balancing service that handles all of the incoming traffic to the application. Or to collect feature usage data, we can directly stream from the services that provide these features. And for the text messages that Victor has mentioned, we can use a snapshot of the hot and cold storages that contain recent and archived data.
And finally, we actually collect the data. So how can we go about collecting the data? Well, there's two ways to do it. First is a quick and dirty approach. Take snapshots, samples of the data from various product teams working on the features, and do your analysis and reporting on it and be done with it. But of course, this is a bit lazy. It's quick and dirty. The data's not always up to date. It's not a single source of truth. Anyone can do whatever they want in any kind of fashion and arrive at different results. The second way is longer, more complex, but it pays off in the long run because the data will be up to date, it's a single source of truth, and it's consistent and timely. And that being building out a data pipeline. The second reason for introducing a data pipeline is it gives us something to talk about here today and about the product data lifecycle. So let's start introducing that.
The first very important element of the product data lifecycle is the data origin or the product itself. The data is generated through the usage of the customers, and we call this data raw data. After we have the raw data identified, we can continue with the extraction of the data. As I mentioned, the data sources can be different tools and technologies, so we don't have a universal way to extract this data. And we can have different solutions for that, but the goal of all of them is to copy the raw data from the data source into a centralized place. So it can make the next phases easier, and also we can maintain the history of data. Imagine that the raw data is just a bunch of text, bunch of different files with different sources in a variety of directories. The next step is to perform a variety of rules and standards and so on over the raw data set in order to ensure its quality, accuracy, and integrity. The transformation phase is considered to be the most important one in the life cycle of the data, because it ensures that the data is going to land in its new location, its best state, and ready to use. And the final, the transformation phase is comprised with from several other sub-processes like cleansing to clear different inconsistencies and errors in the data, or the duplication to remove redundant data. Also verification, standardization, and many more. And the next step is to copy the data or load the transformed data set into the new location. Basically here, we not only transform the content of the data, but we have it in another form, like a table. But don't worry about it, because behind the scenes, you still work with a bunch of files and directories. But the different engines, like big data engines, if you have heard of ones, they just help you with working with these files and directories in an SQL manner. And you may recognize that these three phases create the so-called ETL pipeline. And another very important part of the pipeline are the people who are responsible for building it. These are different experts like data, software engineers, SREs, DevOps. And the necessity of having so many different experts is defined by many factors, like how big is your data platform, how many resources do you have in the company, what's your use case, and many more. But in Quack, imagine that the data engineer understands from all of these things. It has very wide expertise. But this is the case sometimes in reality. Also, the data engineer is its own quality assurance, because he's testing the whole ETL pipeline as well.
And of course, having ETL, having your data pipeline and transformations and loading of the data in a transformed form is all nice and all, but you first need to have a use case for it and to actually perform something actionable with it. So the following steps will be focused on data consumption, and the first of these is to actually do analysis on your data or consume it in some way. Now, by analyze or analysis, we mean anything that's like simple aggregations, group by, taking out some simple summary statistics from your data. It could be something more complex, like doing statistical testing, things like A/B testing on your features of the data that you're collecting, seeing if users are using new features that you're deploying. It could even be building out machine learning models. So for example, like customer churn models, things to do sales forecasting, or predicting API demands that you can properly manage, I don't know, your load balancer, for example. And analyzing it also isn't enough, because analysis would be kind of meaningful or wouldn't speak to anything or anyone if you don't have visualizations or some kind of way of consuming the analysis. So here what we mean is, of course, once you've built out your machine learning solution or statistical analysis or whatever kind of thing you're looking at, is to output it either through dashboarding tools, maybe like Tableau, Click, other kind of tools, or Power BI, or any other kind of BI tooling that can let you visualize and consume this. Either people like business analysts, product managers, other leadership personnel who will be making decisions on this kind of data. So all in all, like I mentioned, this is data consumption. And the data consumers are people like data scientists, data analysts, BI analysts, and etc. who will be working and processing this type of data coming from our ETL pipeline.
And without offending my fellow colleague and any other data scientist, this is how you can imagine the relationship between these two people in a real-life example.
Indeed. I mean, between the data science team and the data engineering team, there's always a communication that happens, you know, to understand the data requirements, what data is needed, and how we can go about collecting it if we don't already have it. And already, like I mentioned already and hinted at, the whole purpose of performing both the data collection, analysis, visualization, and all of that is to provide insights and have high-level stakeholders, product managers, business analysts, other leadership personnel who will be consuming these outputs and coming up with actions to take which will affect, of course, the user experience through the product features, any changes or new features introduced. That'll affect how users experience the product, and of course the data we'll be collecting in future for the product, hence the product data lifecycle.
Talking about insights, what did we find about Quack? Well, we found that our customers, they love sending gifts, so we decided to add this as a feature. We didn't have it as weird as it sounds, not only to reply to messages, but to react to messages. How did we find it? Well, we found that our customers sent a ton of giphy links with ducks inside. Probably that's an explanation why they subscribed to us at first place. But anyway, we also decided to add a reminder via our chatbot for colleagues' birthdays, and the ability to generate a personalized message and send them, so we can make the workspace more happier and a better place.
And indeed, again, the whole purpose of this data lifecycle, the data pipeline analysis, is to help the business make more optimized business decisions and such that, you know, it's in a data-driven way. So, you know, why get a cat palace if, you know, a cardboard box will make the user just as happy, or if it's actually their user needs.
Even though I have a cat palace for my cats, I agree with that. Anyway, everything looks very good for now. We achieved some of our business goals. Our customers are slightly happier. But even though this whole pipeline looks neat, shiny, and straightforward, building it was not like that at all. We had a lot of issues and problems, and they resulted into very inefficient and unproductive way of working in our data team. So this again resulted into increase of the cost of operations and our expenses. So we've identified the reason behind this is we don't have processes and practices enforced into our organization regarding the data management, or AKA we were lacking the data governance strategy.
And so what exactly do we mean by data governance? Well, if you go down the rabbit hole of Googling this, you'll find anyone and everyone who gives their own definition of this, who also provides, you know, what they think is the most critical aspect of data governance. But a simple way to put it is simply like Desi mentioned, the rules, policies, guidelines, and procedures in place that help the organization both manage its data pipelines, the entire data lifecycle, also its data teams, and overall helps it with compliance in regulatory aspects and any other kind of laws in place for this.
As Victor mentioned, the data governance is a key for compliance with different regulations, laws, and policies enforced outside of your company in a different levels in a country, industry, and so on. What happens if you're not compliant? Well, you may get sued, you may get fined. It's going to damage your reputation in front of your customers. Basically, you don't want this. And how is data governance helping? The easiest way to imagine, although that's not the explicit thing, like there may be more, but if you are a data engineer and you are requested to add a new data set, to introduce a new data set into the data lake, instead of freaking out or not caring at all, if you are compliant, you may follow a steps or a standard practice. What are you going to do if your data is sensitive or private and so on? Like, first, I may need to classify this data. Then, if it's anything done public, I will go through different reviews, like privacy, legal reviews. Then, I may need to have some guidance to understand all of these policies and regulations so I can find the best technical solution to comply with them, because you don't only need permissions to process these data, you need to find the technical solution to comply with them. An example to imagine, you may need to store specific data for a specific country or set of countries only in this area. Or, for example, you may need to process this data only after obfuscating or only after you're aggregating the data. Or you may need specific rules for data retention and so on.
And after dealing with making sure from the start that we have privacy and security baked into our processes, of course, firstly, we also want processes that help us maintain data quality. So if maintaining or examining data quality sounds a bit broad and vague, that's because it is. Even myself as a data scientist, the checks I do to check that the data is of high quality or if there's any issues with it vary project to project, data source by data source, depending on what kind of data and what kind of use case I'm looking at. But overall, the types of checks and the type of criteria we're examining when we're examining data quality is looking for data integrity and completeness, basically making sure that the data that we're consuming in its transformed form after the ETL processing essentially reflects that nothing has been lost or dropped along the way from the raw source that we need to the transformed form that we have, either through being aggregated away in any of the pre-processing steps, being dropped as part of some kind of filter, and essentially that the data is of good integrity. Other concepts, for example, timeliness and consistency. So for example, a lot of the time, depending on what kind of data pipeline you have, you can often have use cases where you're streaming data in real time. You can also have batches every day or every hour or in some kind of periodicity arriving in your data lakes. And essentially, it's basically making sure that the data is consistent, it's timely, and that it's you don't have any gaps in your data. And if they are, how can we address those, and how do we have any backups in place to prevent any kind of data loss? And then the final two are validity and accuracy, which is kind of also tied to data integrity and completeness, but essentially also checking with high-level stakeholders, product teams who are close to the data origin and who are essentially the data producers and final users of the data, that the values that we're collecting align with what they want to use in their use cases, and that, again, it reflects what users are experiencing in the products and what they're essentially inputting into our data pipelines.
One more thing to add to what Victor said, all of these things, they can be either a good practice that the data team will follow, or you may configure all of these quality criteria in automatic tools that will check all of your data sets and check if these quality criteria applies to them. And it will alert you if anything happens, so you can proceed on fixing these errors and anomalies. And the next thing that Victor mentioned about data governance is that it helps the data personnel understand what kind of data assets we possess. One of the things to do that is through very good documentation. But I would like to ask you something. Raise your hand if you ever experienced any difficulty in finding the perfect documentation, like ever in your experience working in the industry.
I'll go first.
Second question, and the last. Do you love writing documentation?
I'm also not raising
surprised.
my hand.
Anyway, this gives you some insights. First of all, it's better than having nothing, but it's a manual work. As you saw, it's not very efficient. And it requires discipline from the people who are going to write it and maintain it. Plus, it may not be unified and not up to date because it requires maintaining it from different people's perspective. So in data management, we have more advanced ways to maintain what kind of data assets do we have and visualize, so we can help different data stakeholders to identify and meet their information needs.
The first example is data cataloging. So essentially, a data catalog in a single sentence is essentially just a centralized repository or documentation that governs what data sources you have in your organization, who owns this data, maybe some descriptive descriptions about the fields that you're collecting, what kind of values you can expect in them, and also, in many cases, also describing the use cases that currently exist in your organization that use this data. And it's easy to imagine what it looks like actually if you don't have any centralized repository or means of tracking or cataloging your data. And you can imagine that our organization, Quack, has exploded in popularity, received a new round of funding, and now we have 5 new feature dev teams, new product managers. But now the product managers want to analyze our existing features and how they're being used, and also new features that are being introduced. So first you need to find points of contact of people who are working on these features to understand the data that is being produced. This wastes time of both the product manager, who has to scout out people and points of contact in these teams, and also time of the feature dev teams who want to work on their features and not have to deal with how exporting their data, wondering how to do this, and so on. So having a centralized repository or data catalog essentially helps alleviate this because it has a list of where these data sources are from, who the origin point of this data is. If there's a data team, who's the data owner of this, where can we find this, how can it be consumed? And product managers can also quickly understand what are the use cases in which this data is currently being used. And again, it can be something as simple as a Confluence page, which just documents, and you just have to make sure that you market this well enough in the organization such that everyone can refer to it.
The next item is the data lineage. It uncovers for you the full data lifecycle, and it helps data people understand and visualize it from start to finish, from data source to data consumption. Basically, it gives you a lot of context about this whole life cycle, like the business logic, different technological information, all the transformations that the data went through during this life cycle. And by that, it really helps, especially the data engineers, find out the problems that may appear during this life cycle. For example, if Victor comes to me and say, okay, this field here in this table, it's Boolean, it's true, but it's supposed to be false because I've set it this way in the UI. Can you check on where exactly does the problem appear? So you remember the pipeline, it wasn't like one step, it was like a lot of steps. So by going to the data lineage, you can go and check all of the context that you need, and identify different failure points, check all of them, and of course proceed on fixing it without risking breaking anything else, because most of these problems are context specific, and it requires you to understand it in details. And all of that wouldn't be possible without very good metadata management. So it is helping you to organize and classify your data for complying with privacy compliance, or to elevate different levels of access for security reasons, or to advance your data management and data quality. And last but not least, to achieve great visibility of the data assets that the data project possess.
And then the final thing, before we wrap up torturing you in this last minute of our presentation, is data ownership. So what do we mean by this? And we mentioned it a few times already, who's the data owner and so on. It's one of the most critical aspects of the data lifecycle, and folks will be managing the entire data governance process and data lifecycle because, for example, they manage access rights to the data, controlling who has possession of which data for which use case. As a result, they're also responsible for stakeholder management, making sure that they connect with product managers and the users of the data, understand their use cases, relate their needs to the data engineering team and any other data teams who are supporting on that, and of course, maintaining, like I mentioned, the data governance aspects of this entire process.
Overall, all of these aspects work very well together. They may seem at first that they overlap a lot. I'm sorry, I know we are out of time. I will just have finishing touches. It may seem that they overlap a little bit, and that may make this subject a little bit confusing at first. But data governance, in our opinion, is very important and gives a lot of benefits, and it's very effective. And we encourage people to start working on developing one, although it may be a long process and not very easy, because there is not one-size-fits-all solution. We still believe that the efforts are worth it.
And so we hope that we managed to give you some insight into why using your product data and making effective data-driven decisions is important, and why data governance is also a crucial aspect of this. So thank you. We'll open the floor to questions, and also if there's anything outstanding, find us for some coffee afterwards. We'll be happy to have a chat on it.
So, any questions for t-shirts? There is one, or maybe two, I don't know.
Hi. You have talked about technical documentation, so my question is, usually in my practice, we work on short sprints, we have so many changing requirements, regardless of it's from, is it coming from development side or bug fixes or stakeholders. The requirements are changing so many times that usually if I search for documentation, it is not there, it's missing, or it's outdated. Isn't that even worse? Like this, my question is, what do you think? Is it better not to have something documented, or to have it like not true anymore and outdated?
So that's a really good question. That's also another aspect of making sure your documentation is up to date that I think we didn't mention here. But indeed, this is also why having someone who's a data owner and who's someone who's actually has that kind of a role is quite useful, because they're essentially the guardians, the custodians, and so on, stewards of the data and essentially what it's being used for. So they'll be in charge of also making sure that the documentation is up to date, doing all that stakeholder management and contact with them. And so indeed, yeah, I mean, having documentation, as we all know, isn't always enough. Sometimes you have to make sure that it's always up to date. It could be as simple as also just planning here and there a story point or two in the sprint to make sure that it's up to date. It's also, yeah, it's definitely something that's a problematic issue in organizations. I would still say, though, that it helps to have some kind of documentation rather than none, because at least it gives you a starting point. So, for example, who are the contact points that you can reach out to? If there's any issues like, oh, this doesn't align with what I'm seeing in the data, you can reach out to said contact point and say, hey, help me out here. So yeah, overall, I'd say it's definitely better to have documentation, but yes, it's also an issue to keep it up to date.
And also, I would like to add something. This is why we've talked about the different ways of achieving better documentation through automatic toolings. Of course, for data in data project, but basically there's probably some way of achieving this in other aspects as well.
Yeah, to give a quick example on that, AWS the data lake formation, that helps you if you're using AWS Glue to build your tables and so on. It can extract information and metadata from your schema and update that regularly. So that's like an example of where you can also include automation into the documentation to some level.
Okay, thank you. Other questions? So that was your topic, keeping vital aspects of product data lifecycle.
Yes.
You can ask them further questions outside. Thank you. Thank you.
Thank you.
Loud and word applause for Victor and Desi. Huh?